Alright, let's find the open intervals where the function is concaving up or concaving down and find the inflection points of this function. So first we need to find the possible inflection points in this function by taking the second derivative. Right, let's take the first derivative first. So f prime of x would be equal to 4x cubed minus 6x squared minus 24x. Then let's take the second derivative. This 12x squared minus 12x minus 24. And then let's set this second derivative to 0 and solve for x. So we factor out the 12. We get x squared minus x minus 2 is equal to 0. So let's divide both sides by 12. We get x squared minus x minus 2 is equal to 0. And then let's factor out this the left side. So we factor this out, we get x minus 2 times x plus 1. X plus 1 is equal to 0. So we get two different values. X is equal to 2 and x is equal to negative 1. So these are our two possible x value of the inflection points. So let's plot that. So let's plot the x-axis of our function. So we get 2. No, we get negative 1 here. And we get 2 here. So we have to check 3 intervals here. We have to check to the left of negative 1, between negative 1 and 2, and to the right of 2. So let's pick negative 2 as our test point. Negative 2. Let's pick 0 as the point between the two inflection points. And let's pick 3 as the point to the right of our second inflection point. And plot these 3 values, negative 2, 0, and 3, back into the second derivative of the function. So f double prime. So f double prime. F double prime of negative 2 would be equal to 12 times negative 2 squared minus 12 times negative 2 minus 24. So this is equal to 48, which is suddenly more than 0. So that means that this interval is positive. And then let's check the second derivative of 0. So we plug that in. We get, we just get negative 24, which is less than 0. So the sign changes. between negative 1 and 2. And then let's check the right up to, which is our second inflection point, by plugging 3 into the second derivative of the function. So we get 12 times 3 squared minus 12 times 3 minus 44, which is equal to 48 again. So we know that the sign changes from negative to positive again. Alright, so this means that both of our possible inflection points are in fact inflection points, because to the left of our first inflection point at negative 1 we have positive, to the right we get negative, so it changes sign here. It means this is an actual inflection point. Likewise, for our second inflection point at x equal to 2, the left side is negative and the right side is positive. It means that this is also an inflection point. And the function concave downwards between negative 1 and 2. It concave upwards from negative infinity to negative 1, and from 2 to infinity. So let's write that. So it concave up from negative infinity to negative 1, and from 2 to infinity. And it concave down from negative 1 to 2. And our inflection points would be the first one, the x value is negative 1, and the y value of negative 1, well, we haven't found that yet, so let's find it. So let's plug negative 1 back into our function. F of negative 1 would be negative 9. So first inflection point is negative 1 and negative 9. Our second inflection point is at the x value is 2. So let's plug 2 into our function. F of 2 will be equal to negative 48. So the y value of our second inflection point is negative 48.